All right, so welcome to the Spine Coding Workshop. My name is Nathan Sweet, and I'm here with Soren Nielsen, and we're going to run through how to use Spine at the coding level. So if you haven't already and you want to follow along to run the code as we write some code, you can download Eclipse in the link section. Hopefully you've done that already. There's also the code that we're going to be writing is on GitHub. Yeah, so I guess if you guys have any questions while I'm talking, feel free to just make sure your mic's unmuted and jump in. Or there's a raise your hand button you can press. Or you can type something into the chat box. So feel free to interrupt at any time.
Cool.
Yeah, it's good to have an open discussion about this stuff.
Hello.
Also, when Nate is finished with all the stuff he has planned, there'll be a longer question session where if you have any larger questions, we can take those there.
Okay, so let's begin. So if you have downloaded the source code and you have it in Eclipse, or you're just looking at the text files, there's a number of classes that are prefixed with a letter so that they show up in the order we'll be going through them. The empty game class, this is Java, so if you're not a Java developer, my apologies, but it won't be too bad, I promise. So this is the empty game class is the minimum that you need for libgdx to render using OpenGL. So mostly you don't have to worry about any of this. So what we'll do first is show how to load the spine data from files. So it's already done in the source code that you're looking at probably, but I'll type it again because it's more thorough that way. So the first thing we need to do is create a loader. Wrong. The first thing we need to do is create a texture atlas. This is where the images will come from. In libgdx, you create a file this way. So we have on the file system, we have the assets. Sorry, this is the wrong place. We have an assets folder that has files in it for SpineBoy and Goblins. And here is this SpineBoy atlas. We'll go through how to pack your images into atlases later. But the atlas looks like this. This is the individual SpineBoy images packed into one larger image. And the .atlas file is a text file that describes the offsets for each image that has been packed into it. So once we have an atlas, we can create the JSON loader. There's also a binary loader that works exactly the same. It's called skeleton binary. They have the same methods, just one loads a JSON spine data and one loads binary spine data. So if you're doing this in another language that's not Java, the methods to load the data will be the same. So we're going to load skeleton data, read skeleton data. So that is the skeleton file that Spine outputs. That would be this one, spineboy-skeleton. These JSON files are exported from Spine by going to the menu in the corner, clicking export, choosing JSON, and a directory for it to output. You can output JSON or binary in this way. Doesn't really matter which you use, JSON or binary. Some of the runtimes don't read binary just because it's easier to parse the JSON, so that was done first. This method returns a skeleton data instance. And so the skeleton data that holds all of the bind pose information for the skeleton. So now we want to create an actual skeleton instance, and this is what we'll be drawing. If I imported the right class, which I didn't. libggx has a skeleton class, so you have to be careful when you import to choose the spine skeleton class. So now we have a skeleton. We can draw it. We cannot draw it. So before you can draw it, do that. Yes. So update WorldTransform. A skeleton, we'll go into details about the object model, but really quickly, the skeleton, I wonder if that's a good idea. Yeah. So the skeleton has bones, and the skeleton data has bones. So trying to decide what is the best way to show this. Yeah. So each bone has a local translation, rotation, and scale. And so they also have a world translation, rotation, and scale. And when you load the skeleton, it hasn't updated its world scale, rotation, and transform from the local SRT, we like to call it. So you have to call update world transform, and that will go through all the bones and update them so that they can be drawn in the right place. So as you can see, the libggx uses a 0, 0 in the lower left corner. Yeah. So if we wanted to move where we draw the skeleton, we need to get the root bone from the skeleton, call it root, and now we can set the local translation. So we set x to 220 and say y to 20. So it moves the skeleton over, and that's how you typically position your skeleton, is by moving the root bone to where you want it, and then you have to remember to call update world transform. If you don't, then the world transform will stay what it was, and you moving the root bone will only change the local values for the root bone. So you see the root also has, sorry, get world x and get world y, and those are the transformed world values. But we won't worry about that right now. So one of the things that's tricky when you're positioning, oh, we'll do that in a second. Okay. Right, so, yes?
Hey, are we gonna get into more details about this update world transform later?
Yes, we are. Yeah.
Okay,
We'll
sorry.
go
So
through
I'll just wait. It's okay.
Yeah, I wanted to quickly show how to load and render the skeleton, and then we'll go into details about the object model and the data that's being stored.
Okay, awesome. Thanks.
So I guess now we will load some animation data. So there's only two methods: read skeleton data and read animation. So read animation takes a file and skeleton data. So for this, we will load the walk JSON file. So read animation returns an animation, which we will assign to a new field. So once you have your animation, the way that you apply it to the skeleton is simple. There's an apply method. This apply method takes a skeleton, and it's going to pose that skeleton at the time that you specify. And this third Boolean is tells it whether it's going to loop or not. If it doesn't loop, then when the animation gets to the end of its duration, then it we'll just position the skeleton to the last frame in the animation. So the time value is 10 seconds. It's a float. And so we want to have a field that will be incremented every frame by the difference in time since the last render. So in libgdx, you do that like this. We will go and create a float field. And that's all you need to do. So we've loaded our skeleton data and our animation. We created a skeleton instance. We position it, and we apply the animation to the skeleton. So this poses the skeleton's bones. It sets all the local transforms for the bones. And as mentioned, you will need to then update WorldTransform so that the bones WorldTransforms are updated. I guess we can talk about that more since there's a question. Each bone has a local SRT, scale rotation transform, and the bones are arranged in a hierarchy. So some of the bones have a parent bone all the way up to the root, and the root has no parent bone. So what update WorldTransform does is it starts at the root, and it transforms the root bone. So that means it's going to position the root bone at its local x and y with its local scale and rotation. The next bone in the hierarchy, it will then position relative to where the root bone is. So if the root bone is rotated 45 degrees, the next bone will have its whole coordinate system that it is positioned within also rotated to match the root bone, 45 degrees. That's how you get the forward kinetics for when like an arm moves. The upper arm moves and the lower arm moves with it without having any of its values change because the coordinate system for the lower arm has moved. Hopefully that makes sense. I think it'll make more sense as we keep going. But basically, to reiterate, the animation is posing the skeleton, changing all of the local SRT values. Update WorldTransform takes those local SRT values and applies them to all the bones. So now the bones' world SRT values will be positioned in world space. And then when you draw it, you'll get the bones in the correct place for that time in the animation. So I'm going to slow down the animation because this connection is probably not really fast. But this is the walk animation playing in a loop. Are there any questions so far?
Looks like you answered David's question.
Yep.
Hopefully.
Yeah, I just wanted to know if you needed to call that on every frame.
Yes, if you change the local, anytime you change the local transforms, you're going to want to call that so that when you draw it, you get the bones in the right place. The drawing uses the world transforms.
And I guess you call it also if you change the world transform.
You can't actually change directly the world transform. You can only change the local transform and then have it apply that local transform to all the bones to get the world transform.
Oh, okay. I'm using a different technology. I'm using Corona. I was just imagining how you would make the landscape translate, for instance, stuff like that.
The landscape.
Yeah. Don't worry about it. I'm just gonna understand while you explain. Don't worry.
Okay. So one of the things that is tricky here, well, say we wanted our guy to walk across the screen because right now he is walking in place. So one way to do that is we pose the skeleton, then we get the root bone. We could have assigned this to a field, but we didn't. So now we want to change the local value for x. So we'll get the current value and we'll add, I'm going to move this delta into a variable, if I can spell. So we're going to say he's going to move 100 pixels per second. And there we go. Now he slides across the screen. Slides right off the screen. So again, this is how we position a skeleton is by getting the root bone and setting his position. If you key the root bone, it will be pretty confusing to you, because when you apply the animation to the skeleton, keying the root bone will then, if you key translation, will move the skeleton. It will change the root bone's local X and Y values to whatever the animation has. And then when you do something like this, where you're getting the current value of the root bone, it will have been changed by the animation and your guy won't move. So be careful not to, you almost never key the root bone translation, because that is used as a reference point to position your character or your animation. So typically,
Got a raised hand.
oh, do we? Sorry. I don't see the raised hands for some reason, so go ahead.
I got a quick question here. When it comes to actually defining the loading, like what you've done, I've noticed that for the skeleton JSON, you're passing the texture atlas into it. Now, what happens, this is just an example, if you just want to have a skeletal animation that doesn't have any textures applied to it. So let's say, just kind of put it out there, let's say I want to have a skeletal animation sequence interact with an already preloaded spine character. So all it is all I'm doing is I'm just utilizing the movements of a specific bone to interact with the root bone, and then moving a spine character on screen with that bone. Is that possible?
Yes. Yes, actually, if we go into this constructor that takes an atlas, you see it's a shortcut for creating a texture atlas attachment loader. It's just because most of the time you want to use an atlas.
Right.
You could also pass in an attachment loader into skeleton JSON, and it will use that to, if we look at attachment loader, it's an interface that has a single method that takes a type and a name and returns an attachment. So for most of the attachments in Spine, they're going to be a region attachment. The attachment type will be a region attachment, and the name will be used to look up that region in an atlas. But this mechanism, you could create an attachment loader that does nothing, because you don't need to load anything for your region attachments. There's no regions in your scenario. In other scenarios, you might want to use the name to maybe look up an SVG file on disk and render that SVG to some texture atlas and then return that region. So you have complete flexibility over what the attachments, how the attachments are created and what they're going to do, like where they're going to get their regions from, or however they want to draw.
Perfect. Thank you.
Sure. One more thing I'd like to talk about before we go away from this simple example. Sometimes you want to scale your skeleton and all your animations because you have images that are, say, twice the size or half the size. Say you have a high quality or an HD version of your game. In that case, the JSON, the skeleton JSON and the skeleton binary loaders, they have a set scale method. And what this does is everything loaded after you set this will have its size increased or decreased, multiplied by the scale. If we run it, now we have a very large spine boy. And if the images were 1.5 times the size, then he would use the images that are larger and everything would work as you expect. You can also go smaller, of course. A little tiny spine boy. And so that's actually scaling the local positions of all the bones in the skeleton, as well as the translations in the animations. Another way you can make your skeleton scaled is by changing the root bone. The root bone has a local scale, translation, and rotation. So if we were to scale the root bone by 1.5, we will get the same effect. But there's a difference here, because when we're scaling the root bone, all of the positioning done by all the bones stays with the same values. Like we're positioning the root bone at 2020, and that's different from using the scale in the loader, which will actually change all of the values on all of the bones, and that can make a difference if your game depends on those values being in a certain scale. It's up to your game, but if you care about the distance between bones and the magnitude of the values that are that the bones actually use, then you can use scale on the root bone. Otherwise, you can use it in the loader.
One more quick question for you. When it
You
comes
have another
to
question?
scale, oh yeah, sorry.
Yeah, go ahead.
When it comes to actually modifying the scale, will that have a future impact to the bounding boxes? I've heard that they might be like a vertices rather than a solid square. So how would that impact your scale?
Yeah, so the bounding boxes will be just like the images. So a region attachment in Spine is, you can see it here, like the head here is made up of 4 vertices. The bounding box will be exactly the same, except for there won't be a texture to draw, so there won't be a head there, it'll just be a box. In the UI,
Okay.
you'll draw a box and you'll attach it to a bone the same way you do an image. And it'll be transformed exactly like images are transformed in the runtime. So what you'll have to do, because certain transforms on the regions can cause the bounding boxes or region attachments to become non-rectangular. They're actually 4 vertices. It's actually a polygon. It's not just a rectangle. And you can see that. So
Right.
if you were to rotate the head so that it is, say, about 45 degrees from the bone, and then you scale the bone in only one direction, you can see the head is scaled as you'd expect. But when you look at the actual bounds of the head now, you see it's a diamond. It's a rhomboid. So that can be a problem if
Okay, perfect.
if your game toolkit doesn't support drawing a diamond shape quadrilateral and it can only draw rectangles, then you won't be able to do this if your images are not aligned to the bone. So you can see if I grab the image and I rotate it, you see it's a rectangle now because the image is aligned to the bone. But as soon as you get any rotation that's not aligned, you have a problem. So every 90 degrees, you'll be fine.
I didn't even know it had that function, to be honest with you. That's awesome.
Yeah, it's a little bit tricky, but that's what happens when you start scaling things non-uniformly. If your toolkit doesn't support that, what you can do is when you scale a bone, as long as you scale both axes the same amount, then it's always going to stay a rectangle. So you're fine. It's either that or align your images to the bones so that they aren't skewed.
Okay.
Yeah, just a small addition to that. If you want to make absolutely sure that that it's actually has the exact same rotation as the bone, you can set the axis to be local instead of global, and then just set the rotation to either 0 or 270 or 90, whatever.
Yeah.
Because then you're absolutely sure that you'll have no type of distortion going on.
Yep. Cool. Okay, so I think we can move on now to talking about attachments. So get back up. So there's this class called deattachments. I'm going to run it first so that you see what it does. So this character is walking, and when we press the numbers 1, 2, 3, 4, 5, 6, it puts an attachment in his hand. So this is how you would change what what weapons a character is holding or what armor they have. In the code, there's a switch statement for what key you've pressed. And Skeleton has methods to set the attachment. This is really keys 1 and 2 are really a shortcut for what key number 3 is doing, which is getting an attachment from the skin, or from the skeleton, and this is the slot and the attachment name. So it says for the right-hand item, find the dagger attachment, and then it finds the right-hand item slot, and sets that attachment to the slot. So in Spine, if you look at, that's the left hand. If you look at his right hand, you'll see he has a right-hand item, and one of the attachments underneath that slot is dagger. So that's the attachment that we're finding there. The other hand has a left-hand item, and it has a dagger and a spear. So these are the things that we're attaching. When the skeleton gets the attachment, the way that it does that is, well, first let me show you skins. So skins are a way of reusing all of the bones for a skeleton. So you have the same skeleton, but you want it to look differently. For example, we have 2 goblin types, and they have completely different looks, but when they're animated, they animate the same way. They use the same animation, but they look completely different. So to do that, we use skin attachments. Underneath the slot, instead of having the image for this goblin head, which is a green goblin head, directly under the slot, you can say new skin attachment. And that creates this node here with an orange puzzle piece. Then you attach the actual image to that puzzle piece, that skin attachment. And you'll notice when I change the skin that's active from goblin to goblin girl, the goblin head here, instead of being goblin head, it turns into goblin girl head. So the actual image that's used for a skin attachment depends on what skin you have. So the reason that we do that, there's a level of indirection there. And the reason that we have that is, you notice in this animation, the eyes will blink. So right there, her eyes close. If you look in the dope sheet for the head, these yellow keys, that's the eyes closing and then opening again. And it does that, you can see it here in the tree, this eyes closed. So you have a slot on the head called eyes, and it has a skin attachment called eyes closed. And that's getting shown. You can see the image. If I was in setup mode, you could see the image. So if we were to show the goblin girl's eyes in the animation, we wouldn't be able to reuse the animation for the goblin because he also has eyes and they're different. They're different image. So because we have that indirection using the skin attachments, we can have the animation change images without caring that it's a purple goblin girl eyes or green goblin guy eyes. So that's a little bit tricky, but that's what skins are for. They're for reusing animations for the same skeleton so that you can have same skeleton look different with all your animations. Skins are not for equipping items. If you just want to equip an item, like a dagger or a spear, then you would just not use skin attachments. You would just attach those images to the slot that you want, and you're done. In your runtime, you would say, set the attachment for this slot to this image, and it shows it. You don't need skins for that. One of the tricky things you'll run into the first time you try to use skins is that this is the same code from the last file. is we have a JSON loader, we load a JSON, we load a skeleton data and an animation. We create a skeleton, position it. This time we set the skin. This looks up the skin by name, by the way. So once you set the skin, if we don't do this, set slots to bind pose, it doesn't show anything. Oh, you saw it blinked. During the animation it blinked. So it showed that image, but because when you set the skin, it doesn't know that you want to change any of the attachments in the slots, it doesn't change the attachments for you. So you're going to need to call set to bind pose or set slots to bind pose. Set to bind pose will set all the slots and bones to the bind pose, and set slots will only change the slots. So this will look in the bind pose, and the bind pose, if you're wondering, is this pose, the skeleton as it looks in setup mode. We call that the bind pose. So if you set the skin for the first time, then you'll need to do this. If you look at the Java docs for set skin here, I'll paste these into the chat. So this is what set skin does. Sets the skin to the attachments that are currently attached. So once you have your skin attached, once you have your skin used and all of the attachments from the skin attached by setting the slots to the bind pose, if you later change the skin, it knows that, for example, the goblin head is attached. And so when you change to a different skin, it looks at that skin, and if there's an image for the head skin attachment, then it will use it because the old skin had that same skin attachment and it was attached. So that's a little tricky, but that's a.
You had a raised hand.
Oh, okay. Go ahead.
I got a quick question about the items. Is it possible? I'm not sure if it exceeds the limitations right now of Spine, but can you put all your attached items in a separate atlas so that way multiple Spine characters could use the same attachments? Because right now I'm looking at it, and I'm looking at the goblins.png, and I see that the attached graphics are all in goblins.png. So if I had, let's say, goblins 2, and they also use the same knife, would I have to duplicate that knife PNG? Just for that other character?
So you might want to. So the reason to use an atlas is because each time we draw one of these little individual images, we don't want to have to do a texture change, a texture bind, because that's expensive. And we're going to draw, like 15 or 20 little images. So if we put them all in one bigger image, then in most game toolkits, it's much faster to draw. So if you can fit all of your images for all of your characters into a single atlas, you should do that, because then you can draw multiple characters and it will never switch which texture is the currently bound texture. But it's really up to you how you resolve your regions to your region attachments in Spine to regions in a file. So again, the skeleton JSON takes an atlas, which really just creates a texture atlas attachment loader, or it takes an attachment loader. So you can create an attachment loader that looks up an attachment name in any number of atlases, so that you can have 4 or 5 atlases and pull in images from all of them. You don't have to duplicate them.
Perfect. Awesome. That's just what I was looking for.
Okay, cool. Yeah, so the rest of this is the same. We draw in the same way. The only addition in this file is setting attachments. So if you set an attachment to null, it will clear the attachment for that slot. You can get the slot directly and set its attachment, You can also get what attachment is on that slot. So here we change the skin to the girl, and the attachments stay because they're not in the skin. So
In regards to the attached skins, I know that in the future you'll have animations being able to use that. Will animations also be applicable to attachments as well?
not for a while, at least.
Okay.
It's a lot easier to think of everything as being a bone. So anything you want to animate is a bone. As soon as you start animating individual attachments, it makes everything more complicated from the UI all the way through to the runtimes. So that's why we
Right.
decided that
Okay.
if you want to animate something, you have to make it a bone. What you can do, though,
Okay.
is you can have, if you wanted his head to, yeah, trying to come up with a good example on the fly. If you wanted to animate an individual image, what you could do is create a bone specifically for that image and then animate it using that bone, and you'll get the same effect.
Okay.
It will seem that you're able to change that image however you want to change it, but you're really only changing the bone.
Okay.
So when to use skins is a little tricky. Using attachments is something that your application needs to manage. You need to know when to set what attachments. So someone gets a power up and now you need to put on armor. Your game is going to have to know what slots the attachment needs to go on, and set them or clear them. So if there's no more questions, we'll move on to transitioning between animations. So often, let's see. Just changing this a little bit. So here we have a walk animation, and then after 1 second, well, it's slowed down, I think, by a factor of 6. So then he switches to a jump animation. So I'll play it again, and notice the switch is very abrupt. He's walking, and then suddenly he's crouching at the start of the jump animation, and then he's jumping. So that's kind of ugly, and the way to fix that is to mix the two animations together. So to do that, you apply the first animation that you want, which is the walk animation. This is a little tricky. The timing, yeah, the timing for this is a little tricky. But so if we've been walking for more than a second, then we want to mix with this line. This will apply the jump animation to the skeleton. And then it has a fourth parameter here, and that's an alpha parameter. That allows you to mix the current pose with the jump animation. So we apply walk, and then we apply jump, but we mix it so that it doesn't just set the skeleton to the jump animation. It sets the skeleton somewhere between wherever the walk animation is and wherever the jump animation is. So then the rest of this code, the jump time and the mix time, that's going to be a value between 0 and 1, which is the percent to apply the jump animation between the current pose and the jump animation. And we're going to have that change over time from 0 to 1 so that we transition from the walk animation to the jump animation smoothly over time. And the time that we're going to use is 0.2 seconds. I'll make it a little bit higher so that you can see it, 0.4 seconds. So this is what it looks like with mixing. After a while, he will transition to the jump animation smoothly. And so for the first 0.4 seconds, he was in between the walk animation and the jump animation. And that gets rid of that abrupt change. So watch it one more time. Hopefully you can see it with the presumably slow frame rate that we have on the meeting.
It's okay. Nice.
You can mix, 3 or any number of animations if you wanted to. I'm not sure there's a use case for that. But. So the problem with this is that, well, was Mario able to get in? Yes, cool. Welcome, Mario. That's Mario Zechner from libgdx. So managing this state is pretty ugly, as you can see, and this is a custom-coded state machine for this example, and it's nasty. So there's a better way, and this is a little helper class that I wrote just before the meeting, and it's called animation state. So what you do is you create an animation state and you define the mixing between any number of animations. So this says that between the walk and the jump animation, you want to mix for 0.4 seconds when transitioning between those two. And you can have many of these. You could say between run and jump, transition less, so, and the animation state stores all that stuff. Then you tell the animation state what the current animation is and whether we're looping, which is this method. Then instead of applying the animation, you use the state to apply the animation to the skeleton. And that handles all of the fancy state machine logic that you need to transition from one animation to another, because it knows what all the animations are and how to transition from them. If there's no transition, then it won't use any. This line of code is saying if the time has been greater than a second and we're walking, then set the animation to jump without looping. So that's a lot better than the last code, which had a lot of if statements and math and division and things. So if we run this, it will look surprisingly familiar because he's walking and then he transitions smoothly to jumping. But he does it with code that's a lot cleaner and easier to use. So the animation state class, because I just wrote it, is not in libgdx or anywhere. It's only in the workshop on GitHub. So we'll make that available somehow so that people can use it, because I think it's a pretty clean way of doing it. So next thing I'll show is I have Spine Boy over here. So here's Spine Boy. I have an animation called Walk, which you've seen probably many times because we use this walking animation a lot. I have another animation called Bow. This is it equips a bow in his hand, and then it looks like he's pulling back the string on the bow. There's no string, but don't worry about that. If you notice though that the only bones that are keyed are from the torso and above, so it doesn't key anything on the legs. So what we're going to do is say we wanted Spine Boy to be walking, and then we wanted him to be, while he's walking or running, to pull out the bow. So what it looks like is this. So it's applying the walk animation, and then it's applying the bow animation on top of it. One of the tricks that it's using is it could just apply the bow animation. It'd make for a lot simpler code here. Oh, I need jump time. If we run it now, sorry, I didn't know if you saw the code. What I did is I replaced, if we've been walking for more than a second, then just apply the bow animation on top of the walk animation. And that looks like, I will slow it down a little bit for you guys. There. So after a second, it just applied the bow animation, so it was jerky in the beginning, and then when he's done pulling back the bow, the imaginary bowstring, you'll notice that his upper body completely stops. And this doesn't look animated at all because it's finished with the bow animation and it's not looping, so it just freezes. So to fix these two problems, which are an abrupt change to the bow animation and then freezing at the end, we will do something similar to the last example, not using the animation state, but using the mix, except for we will never reach fully mixed. We'll only go up to 95% mixed. And the reason for that is because, well, now because we're mixing, we smoothly transition while we're walking. But the reason to go to 95% is because when he's done with the bow animation, we're getting 5% of that walk animation in his arms and his head movement. And so he looks a little more alive. It just looks better. And you can design your animations with that in mind, so that you mix at smaller or larger value. Like if we change this to 85, you know, his arms are moving a lot more. So he's walking around, he has his bow out. That's one of the neat ways of combining animations that you can do. So next we'll talk about procedural animation. But first let's go into more detail about the object model. So there's a link in the links box. It's called Runtime Object Model Diagram. So that looks like this, which is a very fancy looking chart that describes all the important methods and objects in the runtime. So these class names will be used in all the runtimes. So this applies to everything. At the top, we have a loading box. So this is the texture atlas attachment loader. This really depends on your game toolkit. If your game toolkit doesn't have atlases, then it might be specific to your toolkit. However, you have the attachment loader set up. Then you have the skeleton JSON or skeleton binary class, and those things load the skeleton data and the animation as we've already seen. So the interesting part about these two objects that you get, for the skeleton data, it's the bind pose data. That's everything about the skeleton when you're in setup mode in Spine. So that has a list of bones and slots. They're actually bone data and slot data. And this has the bind pose SRT and color and attachment that you have in setup mode in Spine. It also has a list of skins. So a skin is really a map from a slot and an attachment name to the actual attachment. So anytime the skeleton needs to find an attachment for a slot, given a name, it's going to do it using the skin. There's also a default skin. That's a little bit tricky because the default skin is holding all of the attachments that don't use a skin attachment in Spine. So for Spine Boy, he doesn't have any skins. So all of these images are just attached directly to a slot. There's no skin attachment like this. There's no puzzle piece node. So that means that those images will show in the default skin. If you have a character that has a skin, like the goblins, then this will show in the Goblin Girl skin. This attachment for her torso is in the Goblin Girl skin, and the green Goblin torso is in the Goblin skin. When a skeleton is asked for the torso, it first looks in the current skin, if there's any. If it finds a region with that name, it uses it. If it doesn't, then it looks in the default skin. So that's a way of mixing these two types of attachments, where you have a skin attachment that comes from a skin and an image directly attached to a slot, which it also comes from a skin, but it comes from the default skin. So hopefully you guys got that. If you're not using skins, then you will only have a default skin, and things are a little bit simpler. This is what happens under the covers anyway, so you may or may not need to know. Then we have a skeleton. This is this skeleton holds all of the state for a single instance on the screen. So it has a reference to the bind pose data, and if you create multiple skeletons, because say you have many of the same skeleton that you want to draw on the screen, you can use the same bind pose data, the same skeleton data, with your many skeleton instances. You don't have to load that data each time for each skeleton. The skeleton also has a list of bones and slots, just like the skeleton data. The difference is that these are the actual current position, whereas the bone data and slot data from the skeleton data are the bind pose positioning. So when you apply an animation to a skeleton, it's changing these, and it's not changing the bind pose data at all. It needs the bind pose data because it combines the animation data with the bind pose data to get the current positioning. And it does that at runtime. The way to see that is you have a walk animation like this. If you go to the setup mode and you change this, say you rotate him way back, when he walks, he will, because all the animations are relative to the bind pose, all the animations will continue to work if you change that bind pose. And because the animation data is combined with the bind pose at runtime, you can do some tricks, like have your character lean based on where the mouse is, or based on if he's running up or downhill. And if you change his skeleton data, his bind pose data, then he will react in that way. He'll lean back when he's running up a hill, for example. Oh, lost my diagram. The skeleton has a few other things. It has the draw order, which is a list of slots. And you can change that at runtime, and it will change the draw order. You can't currently key the draw order, but you can change it programmatically. It has the current skin that's being used. That will be one of the skins from the bone data, or the skeleton data, sorry. You can flip a skeleton on the X or Y or both axes. In the editor, you can't. So you'll design your skeletons facing, for example, to the right. And then in the game, if you want them to face to the left, you'll have to use the flip boolean on the skeleton to do that. It also has a time, and we haven't been using that. Normally, when you update, you will have your skeleton, you'll pass a delta time to him, and that just increments the time on the skeleton. And the reason that we have that is because some slots might depend on that time. The slot keeps track of when the attachment was set. So, for example, if your slot has an attachment that's an animation, like a sprite animation, and it wants to run at a certain frames per second, then the slot, because it keeps track of the time when it was attached and the skeleton's time, you can have animated region slots, for example. So that pretty much covers all of the data that we're storing for a skeleton. We have all of the runtime state for different instances, and then we have the skeleton data, which is the setup pose information. In these ovals are a number of useful methods. So you've pretty much seen them all already. Draw, update WorldTransform, set to bind pose, get and set attachments. And you can set and get attachments directly on a slot. For the animation, animation itself is quite simple. It's just a list of timelines and a duration. The timelines are where the interesting bits happen. So the timelines, for example, a rotate timeline keeps track of what bone it will be manipulating, the curve information, which is the graph in spine, and then for each frame, for each keyframe in the timeline, it has a time and an angle. And that timeline knows how to apply itself to a skeleton to position that bone at the right angle. And the apply and mix methods. One of the things you'll notice that I mentioned a little bit is a region attachment. So the attachment loader decides what kind of attachment gets created. For a specific game toolkit, you'll have a region attachment that works differently from other game toolkits. If you can draw quadrilaterals, then you'll have like what libgdx has. You'll have 4 vertices, and you draw that, and that gives you that diamond shape that can occur in some situations in your animations. If you don't, then like Corona cannot draw quadrilaterals. It can only draw rectangles. Also, I think Pygame is the same way. So for those game toolkits, you'll have to draw rectangles. You can look at the Corona source code, the Corona runtime source code for an example. And in that case, you should avoid non-uniform scaling in your animations and setup pose. So does anyone have any questions on any of the object model? Non-uniform scaling means scaling on X differently than on Y. So if you scale both X and Y, you'll be fine. But as soon as you start scaling one more than the other, it can cause, if your images are not aligned to bones, it can cause the images to be squashed into diamond shapes. And as mentioned, you should avoid that for game toolkits that cannot draw diamond shapes. Yes. I think a couple of people joined, so maybe they missed it, but if you align your image to the bone this way, and you stretch the bone non-uniformly on just one axis, then it remains a rectangle. But if you rotate your image so it's not aligned to the bone, you get a diamond shape when you're using non-uniform scale. So don't do that for Corona and Pygame, but you're fine in libgdx and SFML and others. Okay, so we talked about bones. Now we can do some procedural animation stuff. So I don't have to type it all from scratch. So we have the same code as last time. We apply the walk animation. After 1 second, we mix in the bow animation. But this time we want the bow to aim where the mouse is. So to do that, we need to get the left shoulder, which is done up here. So left shoulder equals skeleton.findBone. That finds a bone by name, storing it on a field because that's, you don't want to look up. It has to go through all the bones and check their name. You don't want to do that in your game loop. So store the bones somewhere where they're easy to get to. What we do is we get the world position of the left shoulder. So this is our bow animation. We'll go back to Spine Boy. It's this shoulder here. And the position of the shoulder is where you see the circle, the slot-looking icon. That's the start of the bone. That's the 0 position. When you say get world X and get world Y, that's what you're getting. We look at the difference between that position and the mouse, and we use atan2 to get an angle. Let me miss. Then we set the rotation of the shoulder to, we're just going to set it to that rotation. So when we run this, it walks for 1 second in super slow-mo, and then it pulls the bow out, and it looks like it's off by 90 degrees. So it's moving when I move the mouse, but it's off by 90 degrees. So run it again. So he pulls the bow out, speeds up, and that arm is now pointing at the mouse position, just because we're getting the bone and we're setting the rotation on it. So we can make it look better, because right now it's nice, it's pointing in the right place, but the rest of him's not moving, and he's still walking.
So I move it a little.
You want it slower? Oh, move it slower? Okay. So pointing up, pointing down, but it's not very lifelike. So to fix that, we will move some more bones. So I'm just going to undo. It's easier. Yeah. So now we also do the same thing to the right shoulder, the torso, and the head. And I'll take this out so you can see what it looks like. And take that out. So he walks, he pulls out his bow, and he's going to point at the mouse. I should speed up the animation so that we don't have to wait so long. Okay. So now you see that the right shoulder, which in spine is, no, show the bow animation. Right. So we're going to move this shoulder and this shoulder. You can click them with the mouse and the torso. So these 4 bones, we're going to rotate them, which is going to make him sort of move his arms, head, and torso to look up or down. It's exaggerated. Like, it starts to bend the head and torso way too much. The arms look good, if you can see that, but the head and torso are moving too much. So to fix that, we can rotate them less. So we'll only rotate them 30% of what we're rotating the arms. And now we get a pretty good procedural animation where he's going to point to where the mouse is with his body, and it looks pretty nice. There is one problem, is while he's transitioning into the bow, he points his arms before he has the bow all the way back. I'll slow it down so you can see it. Slow it way down. So right when he pulls out the bone, right when he pulls out the bow, you'll see that he's pointing his arms way up, and there's a big jerky motion there. So I'll do it one more time. So as soon as you see the bow, you'll see the animation jerks. Yeah, that looks bad. So what we'll do is we're already mixing the bow animation with the walk animation. We'll also mix how much we're rotating by the same amount, so that we won't instantly rotate to where the mouse is looking when we're blending in the bow animation. And that's as easy as just multiplying how much rotation we're doing by how much we're mixing. So now with the mouse up here, as he pulls out his bow, he won't get very much rotation procedurally, and it blends in, and now everything's nice and smooth between walking and pulling out the bow. Nice and smooth. Okay. Any questions on procedural animation and how you manipulate the bones directly based on game events?
Actually, I have one.
Sure.
Could you make one of the bones point at another bone instead of the mouse?
Sure. Yeah, I mean, the math we're doing here is just, the position of a bone and the position of the mouse. If you used another bone instead of the mouse, then yeah, you could have a bone point any direction you want.
Yep. All right. Cool. I was just thinking about the making the right shoulder look at the left shoulder instead, for example.
Hmm. Oh yeah, you could do that. You could also have you can have bones react to things, like say when your character runs by something, you can detect that he's close enough to something in the background, and then have bones be manipulated based on how far away he is. So then, like you're running by uh, a store or something, you could have it look like he's interested in what's in the window, and then as he runs away, he'll be less interested and go back to running. So you can mix the things together. Okay, so next thing we'll show is Box2D. So to integrate spine with physics, um, the way you do it is for all of these images that are attached, you create a physics body and position that in the world. So I'll just run it because it's pretty neat looking. So the boxes fall. The green boxes around the character are static bodies that are being positioned based on the spine animation. And you'll see that the character is interacting with the other bodies in the scene. So it's pretty easy. The way it's done is for each image, we create a body, and then each frame, we get the position of the image, and we put the body in the right place. So the bodies that make up the character are not being affected by the scene, by the physics, but they can affect other things in the scene. One of the nice things you can do is if you were to turn off the animation driving the physics and let the physics take over for the pieces, then you could have a sort of ragdoll effect. As the physics take over, the character would sort of fall to pieces, and you can have constraints on the bodies that make up the character so that he looks good as he falls. This was used in a game, not using spine, but the technique of combining skeletal animation with physics was used in a game called Zombie Smash, where you pick up zombies. The zombies are walking using skeletal animation, and you flick them up in the air, and at that point the physics takes over. They're no longer animating with skeletal animation, and they hit the ground and splatter. So to do it, we have a Limbo also used this heavily for deaths. Yeah, Limbo's a neat game. So we have a texture atlas loader that instead of creating region attachments, it creates box2D attachments. And this is nothing special. This is a class at the bottom of the file. It's just a region attachment that has a body, a box2D body. That just makes it easy to keep track of the body for a particular region attachment. So that loader is given to the skeleton JSON so that any attachments that get created are going to be done with this. Then standard stuff that we've been doing is loading our skeleton and animation, positioning it in the world. One of the things you'll notice is that the scale is being changed. So when you use Box2D, you need your numbers to be very small. You can't use pixels. It's too large for the simulation. Your simulation won't be stable if you use very large numbers like that. So this is setting up a Box2D world that is much smaller than pixels. So we need to scale our skeleton way down, 5% of its normal size. Then we position it like normal. So here's the code that goes through all of the slots for a skeleton. And if they're a Box2D attachment, which they will all be, because of the way that we loaded them. But in other cases, they might be a bounding box attachment or a animated region attachment or something else custom that you're doing. So don't need that line of code. This is doing the box 2D stuff to create a new body. So this polygon shape is using the attachment. So if you remember this dialog, a region attachment has an offset, scale, rotation, and transform. So that is the, if you remember the 0 point, the 0, 0 coordinate for this head bone is right here at the start of the bone. So to position this head image where we want it to be, take that away. If we had it at 0, 0, it would be here. The center of the image would be at 0, 0. So we need to move it up here and rotate it or scale it to get it to where we want it to be positioned. And that offset from the bone position is defined here in the region attachment. So we're using that offset, which is the width and height of the attachment, scale, and the position, and rotation. So we use all of that to position a box in the box 3D world in the right place. So each frame, we do what we've been doing this whole time, which is apply an animation and draw a skeleton. But then we also go through all the slots, find the box 2D attachments, and we transform them based on where the bone is, the world position of the bone, and the rotation. So this is putting each attachment in the right place based on where it is on the skeleton's world position. And that's what gives us the walking guy who can interact with box 2D. If you'll notice, there's many green boxes. There's probably a lot more than you really need. For example, his eyes have a green box. That's a box 2D body that's just not ever going to do anything because the head, everything's going to hit the head before it hits the eyes. So ideally, you wouldn't have so many. Once Spine has bounding boxes, then you can create bounding boxes for where you want your box 2D bodies, and then create the box 2D bodies not from the images but from the bounding boxes. And that would be a lot better. For now, you can work around that. For example, you could use transparent images in Spine and position them where you want your bounding boxes to be. And then instead of using all images, you would go through and have some sort of naming convention. So you only create box 2D fixtures for the transparent images and not for all of the images. Then you would have a lot fewer box 2D bodies. You could do the same trick for bounding boxes. Since Spine doesn't yet have bounding boxes, you could use transparent images. And then when you're doing hit detection in your game, you can get the vertices of those transparent images. You could even modify the region attachment so that you don't have any performance hit from drawing a bunch of blank images, and only use them for hit detection. So I think that's it for procedural animation stuff in Box 2D. Oh yes. So if you're exporting images, you're exporting from Spine as an image. If you wanted the character to be on a specific size, you could create an image that's that size and drag it into the scene. Because it's transparent, it won't draw anything, but it will still use that image to decide how big the resulting output should be when it's exporting images. Okay, so the next thing we'll talk about is texture packing. So here in the links box, there's 2 links. One is to the libgdx texture packer, and the other is to the Code and Web texture packer. So the libgdx texture packer is a command line application. as mentioned briefly, when you have a directory full of individual images, when you create your stuff in Spine using those individual images, when you go to draw things at runtime, you want them packed all into one image to reduce the number of times textures are changed. To do that, you probably don't want to do it manually. You want to use some tool. So the texture packer from libgdx is a free tool for doing that. It's really quite easy to use. This is the code that's packing the Spine Boy and the Goblins images. So you point it at the input directory, which is the individual images, and you point it to where you want it to output and the name of the atlas file that you'll output. So that's going to output spineboy.atlas and spineboy.png. Does it again for goblins. If you want to configure this texture packer, the way that you do it is in your directory where you have all your images, you include a pack.json file. That is a JSON file that has a few settings. Use power of two textures, the padding between textures. There's a whole number of settings here that you can use to do many different things. Yeah. So the documentation explains how it works. You can pack your whole application's worth of images into a single atlas, and based on the directory structure, it will pack images in separate backing pages. So instead of having everything in one image, if you know things will be drawn together, you can put them in separate subdirectories. Or if you know things will not be drawn together, you put them in separate subdirectories, and they'll be packed in separate backing images. The code and web. Oh, yes.
Oh, I was just gonna comment on the code and web. I've only had limited success with that, so yeah, if you can speak to that, that'd be great.
Sure. What sort of issues did you run into?
I had to concatenate multiple. Well, first of all, my primary one was that I was getting issues saying that my skin was null, so I had to go in and then manually edit each individual file with the appended or by prefixing it with the actual, I guess, image or the name of the skeleton, and then so it'd be like the name of the skeleton slash and then the skin that's attaching it to.
Oh, I guess that might have something to do with how the names of images in subdirectories are stored. So in Spine,
Yeah.
you have this images folder, and you can set a path to it. So this says relative to the project file, the images directory, and then everything shown here will be in the images directory. If we were to change this to be blank, then it's saying the project, the directory that the project is in, the project file is in. So we can see images. If we were to use one of these images, the path, the name of that image is the full path relative to where you have the images directory. So you get images/bow. Some texture packers might not use the path and only use the file name. I'm not sure if the code and web packer does that. Honestly, I wrote the libgdx texture packer, so I use that and not the code and web. But looking at it, it has very nice docs. It looks like a really great tool. So you were gonna say?
Oh yeah. Yeah, I got it to work eventually, but what I had to do was every time a skin was referenced, I had to do a print ln on it just to figure out what it was trying to pick up before it would error out. So then I just have to modify my texture atlas accordingly to the actual name and convention that was required. So I think it was kind of what you're saying. The path of the images might have been the issue.
Okay. Yeah, so what you could do is, and probably what you want to do is set the path on this images node instead of having it blank, which is the default, is to set it to the path of your images, and that way you don't have any paths here. That's one way to do it. In some projects, you actually will want to have paths. For example, the goblins have a directory for the green goblin and one for the girl. So the images that you see here, if I just hide everything, these images all have a prefix, which is goblin girl slash or goblin slash. So this would be important, and if you're using a texture packer that doesn't support those paths, that would be an issue. I can say that the guy who writes the code and web texture packer, he's a good guy. His name's Andreas, and if you send him a message, I'm sure he would fix it. So you probably should report that, and I'm sure he'd fix it for Spine.
Yeah, because when you use an image, you just drag and drop it into the texture packer, right? So I don't think it keeps a record of where it is relative to where it needs to be.
Oh,
It just puts the image name, and then if you have to modify it, you have to just edit the atlas file. Maybe I noticed that the Linux version of this texture packer is a little bit out of date in comparison to the Windows and Mac version, so that might also be one of the issues, but not really sure.
yeah, that's interesting. I wonder. He might, it might be a more involved fix then for him to fix it, but it's definitely fixable. Or you could use the libgdx texture packer. Some of the differences between the tools is I think probably the biggest feature that the code and web packer has that this texture packer doesn't is that it can automatically resize things down. So you can pack everything, and then it will also provide you a texture atlas at like half the size, so that you can easily have a HD version of your game and get the standard definition atlas basically for free. You don't have to manage 2 sets of images. The libgdx packer doesn't do that. Yeah, I'm not really sure what else the code and web packer might do. I briefly looked at the documentation, and it's very extensive. It does a whole lot, so it's worth looking at. It's not free though. You will have to pay for it. Spine will eventually be it will eventually have the libgdx texture packer integrated, so that when you export from Spine, you can pack your images at that time, which will be convenient. So I guess that about covers it for the code stuff that I have to show. If anyone has any questions, I can talk about the Spine development and what we'll be doing in the next few weeks.
I got a quick question in regards to asset managers. Do you plan to utilize that in the libgdx runtime?
It wouldn't be hard. Writing an asset loader is pretty simple. I have a feeling that the loading is very fast. The asset manager has other uses though, just for managing all your assets in one place and unloading them between screens and things like that. So it would be great to have. Feel free to send us a pull request on GitHub.
I'm
Otherwise,
contemplating it.
yeah, that would be neat. Otherwise, it might be some time as we have a huge backlog of work from the Kickstarter stretch goals. So it looks like Mario wanted to know if people are using libgdx or what game toolkits are people using. I know that some of the people are using Torque2D. They were one of the $3,500 backers, so we're definitely doing a Torque2D runtime. Also, Cocos 2DX was the other big pledge. Looks like some of the people here are using Corona.
Yes, we are.
Yeah, guys, you're welcome to use your mic if you want to. I mean, to go through questions.
Okay, cool. No, it looks all very well done and very inspiring, but I think I need to play with it actually.
Yeah, jump in, play with it. The in the links box, there's the source code for what I've shown is on GitHub,
Okay, awesome.
so you can look at it. It should be easy to port it to other toolkits if you're not using Java and libgdx. All the official runtimes, it's exactly the same classes and method names, so that it's easy for us to document, it's easy to maintain, and it's easy for users to switch between toolkits. Also in the links box near the bottom is there's two links to the Trello boards for the editor and the runtimes. And those are where we are keeping track of the tasks that we have to do. And so there you can see what we have to do next. You'll see what tasks we're working on next, and you can comment and vote on tasks. So you can vote up your favorite features that are in the backlog, and we'll keep the votes in mind as we move things out of the backlog and work on them.
Awesome.
I got a quick question about the Java runtimes. Will you have JDocs available?
Yeah, I should do that. Yeah, currently the code is on GitHub, but there's no central Java docs, so we'll put up some Java docs. I'll add a task in the Trello.
Also, just for the ones that weren't in on the artist workshop, just linked the recording of that. There'll be an email going out with it as well for everyone.
Awesome. Does anyone have any plans for using Spine in a project that's already underway?
I think I'm going to use it first in a very simple project that I use for demo, which will help me to get used to it actually, to train. But yes, I plan to use it, but I don't know if it's overkill yet for this other project. And I would use it to make plants and yeah, small plants, trees, etc., but animated.
Yeah, I think that's a great use.
Oh yeah, it would be, yeah, definitely.
Yeah, the idea is that it becomes easy to animate many of the smaller things that you might not animate some bushes in your game, but hopefully it's lightweight and easy enough to use that it's not a big deal. And by using it in that way for the little details, it adds a lot of life to the game when things are moving and more interesting than just a bunch of static images.
Yeah, right. Certainly,
Yeah.
certainly. That's the point actually. I'm just wondering about performance at the end, but we need to just try and see how much we can load.
Yeah, definitely.
Cool.
I mean, for things like that, I mean, if you really wanted to go crazy with trees and things, I mean, you could even have wind change. You know, you could have levels where there's a lot of wind, and they would sway differently or more than in other levels. Things like that. That's the kind of power it will give you.
Yeah.
Well, yeah, that
Also,
would be absolutely awesome.
there's some tricky things you can do, like because you're passing a time into the animations. If you have a time that's based on audio playback, then you can have your animations timed to audio, and you can do some neat stuff. Like if you play Super Mario or like the new Super Mario, they have a lot of things timed to the music. So every once in a while, the music does a fun little tone, and then all the plants will kind of like raise their hands and then go back to doing whatever they were doing.
Very inspiring.
Yeah.
I'm interested in trying this out. Right now, I have a project with a couple musicians and artists that we're just trying to put something together that'll hit Linux, Windows, and Mac. But I'm really excited to try this out also with the Ouya, which I'll be getting at the end of the month. So just taking a look at the controller support that I think libgdx just uh, recently got. So I'm really excited to try all of that.
Great.
Mm.
Yeah.
I think this kind of touches on something that was asked earlier, but just wanted to clarify, or maybe I'm completely wrong. Is it possible with Spine right now to attach basically a node, so a second set of bones to, so you want to have a weapon that points at the mouse or whatever, and you want to put that inside a certain node on the main character. Can you do that at the moment?
Hmm. We haven't done that, but I'm trying to think about how it would work, if it's possible. You can
Well,
programmatically change the skeleton, so you could
Okay.
you could actually attach it that way. Another way to do it would be to have two separate skeleton instances, and to position the second skeleton based on one of the first skeleton's bones.
Right, okay, yeah.
So you'd
I
get
can
the
see
root
that.
bone of the
there's
second
this.
skeleton, and you'd set the rotation scale and position based on some bone on the first skeleton.
Right.
There's
Yeah, no,
one
that should
thing
be simple enough.
we had a short talk about, and that was we have the rotation scaling inheritance feature planned to be added. One thing we talked about, but we kind of agreed that we wouldn't do, was to have be able to do constraints instead. So you could actually have a hierarchy outside of the, it would still be parented to the root bone, but it wouldn't. For example, let's say you have you're making a crane. You have something at the end of the crane that you don't want to inherit the rotation of the crane itself. So you could put that so it's not actually parented to the crane tip, but you would constrain the position of it to the crane tip. Um, that's one thing. That's one way to do it, but to start with at
Yeah,
least
that's
one
essentially
thing
the
we'll.
same thing I was talking about, but it's that you would do it programmatically. You wouldn't do something like that in the editor. You
Yeah.
would just
Right.
grab the second
Yeah,
skeleton
that's
and
easy
put it
enough.
in the right place. Yeah. Mario asked about any tips on performance. So um, there's, I guess you could try to minimize the number of keys that you have in your animations. If I mean, you want to use the keys because those are what provide you the nice looking animations. But if you have keys that aren't doing anything, like one of the typical first things is to select all the bones in the first frame and key everything. But if you do that, then you're going to have probably by the time you're done with your animation, you're going to have some keys for, say, translation or something that you don't actually change again. And so that's going to create an animation timeline. It's going to cause, a couple method calls per frame, which isn't that big of a deal, but you could have maybe like 15 or 20 of these types of keys. And so now there's, 3 or 4 method calls. So you could get rid of some, 80 or so method calls just by being careful not to have these extra keys in your animation. One of the tasks on the Trello board is to automatically detect and remove those keys when you're exporting. So that will help for that. Go ahead, Alex.
When it comes to JSON versus data export, is there any performance differences?
Only in loading. The binary loads faster. The file size is smaller. If you zip the JSON, then it's pretty small, but it can't beat the binary. The binary is like the minimal amount of information that needs to be stored. and loading is faster because you don't need to do a bunch of string manipulation and comparisons and things. But as far as runtime performance after loading, there's no difference.
Will also
And just
the
another tip
binaries.
on performance. No, go ahead. Take it
I was going to
afterwards.
say, as the additional features get rolled out into Spine, will the binary exports be backwards compatible? Like if I use a new version of Spine and implement it into a project that I started working on in the start, will it work properly?
Nope. So
Gotcha.
it's yeah, there's no effort made to keep the export data up to date and able to be loaded by subsequent versions. The reason being that it's just not that hard for you to export your data again.
Right.
And it simplifies the loading a lot to not have to worry about old versions. I can say, however, that the data format is unlikely to change, but it's not impossible. Hopefully it won't change and you'll never have that problem, but it could.
Okay. Thanks.
Yeah, just that. There's another small tip on performance. The examples that were made for Spine, all the images were not rotated before they were actually exported out. So some of them they have more white space than they actually should have. So that's one thing that's really good. Like if you select the arm, the upper arm, for example, you'll see it. It wasn't rotated. This is also something you definitely want to do if you don't, if you can't do uniform or non-uniform scaling. You want to rotate them before you actually export them out from whatever editor you're using.
Yeah, and by that he means you would rotate the image in your editor so that the bounds of the image are as small as possible, and that reduces the amount of blank space that needs to be drawn. Because even though you're drawing blank pixels out here, you're still eating up your fill rate, and you're most likely to be fill rate limited on a 2D game, especially when you have many images to draw and they all have lots of blank space. You're drawing a lot of pixels. All of the blank pixels still count against you. That's the most.
Some images you would even want to cut up, like the head. You might want to cut it out into multiple pieces to get less white space. I mean, that's one way of doing it.
Yeah, you could do that. It's hard to say like where the effort would be too much, like where it stops paying off. But if you're trying to squeeze out, every last bit of performance, then you could do that. Of course, you'd wait until your fill rate was your problem, your bottleneck, and then you do the optimizations like that. But as far as the positioning of the bones and the actual extra stuff that Spine has to do versus traditional animation, it's really just fewer keys, and you can't avoid the rest of it. So then it comes down to the fill rate, how many images you're drawing. One thing you can try to do is reduce the number of bones that you have. Each bone has a number of computations that it has to do. But then again, you don't really want to make a character that doesn't look the way, but doesn't look right just because you're trying to get rid of a couple bones. Each bone, it's really pretty negligible cost. If you have 50 characters on the screen and they all have 25 bones, that they add up. But until it becomes a problem for your game, I wouldn't worry about it at all. So. I guess, does anyone else have any more questions or anything you'd like to discuss?
No, that's okay.
Okay. David is typing. Okay, great. Well, I guess I guess we'll wrap up then. So thanks everybody for coming and for backing us on the Kickstarter. We really appreciate it. We're working really hard to try to get you, all the goals done as quickly as we can. So
Well, thank you and congratulations. It's a really amazing tool.
great, thanks a lot.
Thank you.
Thanks.